My name is Mark Grodzinsky. I'm the Chief Product and Marketing Officer, and I have the distinct honor of kicking this off. So I'm going to give you a tight 10 minutes of just kind of giving you a little bit of history of cPacket because, I think it is our first time here, so we wanted to spend a little bit of time letting you know who we are, what we do, how we got to this point. And then I'm going to turn it over to Ron and Norm for the next 80 minutes to really dive in deep technically. We are looking forward to a lively discussion. So cPacket started in 2007, as was the trend at the time as a fabless semiconductor company, kind of challenging this notion that you needed a CPU in order to do some deep packet inspection that could be customized. Said, if you really want to do deep packet inspection at line rate, you need to do it in hardware. So there was a custom ASIC, an FPGA that was put together that actually was able to grep or find a string within within the packets at line rate. So that was done successfully. And then people started saying, okay, well, how do I use this chip that you've just built? What do I do with it? How could you have reference designs? Do you have sample code? Do you have, and so, okay, we might as well just build the appliance. So we went up the stack and actually built the appliance, and people took notice, right? British Telecom in 2012 was building out a 10 gigabit per second network for the London Olympics, and that ran over cPacket. Again, because primarily for network security, because they wanted to be able to run at line rate, but then also all the tools were still 1 gigabit per second tools. So lo and behold, you have a packet broker. So it was one of the early packet brokers that was able to both be used at the Olympics for network security, but also as packet brokering tool. At the time also, the financial institutions started to take notice, because if you're able to do things at line rate and you're able to timestamp packets at nanosecond resolutions, well, people who live and die on the latency of their networks, like electronic traders or network or financial exchanges, they say, hey, can you also capture these packets? Can we analyze what's going on in the network? And lo and behold, at the time, Ron codes up the first, CStore 10, which was our first packet capture device. Again, going forward, once you can broker, you can do deep packet inspection at line rate, you can capture, you can analyze, the whole pendulum starts swinging, everything's going to the cloud. And so now we can do all of those things virtualized and do the brokering, the capturing, the analysis all in the cloud as well. Then, as you guys were talking yesterday, the pendulum starts swinging back. Everything goes into the cloud. They realize how expensive it is. They realize that maybe I don't want all my data in the cloud. And so you start to have these hybrid networks, and you need to be able to have part of your network in the cloud, part of your network on-prem. And then, I want to be able to visualize, and I want to be able to configure command and control across a hybrid network. So that was done as well. And now as we start to deploy much more broadly, and start ramping the business, we start to find that our capture devices are sending about 1 trillion packets a day, and some of these larger hospital groups have multiple CStores. So now you have multiple trillions of packets going a day, tens of billions of sessions running all the time. And how do I know what's really going on in my network, and how do I know what to work on first, right? So using AI to start to analyze and figure out how do I, what should I be doing, and what are those actionable insights I should be working on, is the work that we're doing. So we're very excited to go through all of these steps that we've gone along in our journey. And again, while some of you may not have known us before today, and I, at the social, people will say, oh yeah, I looked you up on your website to kind of, do my homework before the session. That's great. I mean, we've been pretty busy over the last 20 years. And while we've kind of flown under the radar, not always by design, customers who really have mission critical networks know who we are. And that's, the financial institutions. Over 50% of equity and foreign exchange markets go through cPacket today. People who are doing, government work, departments of defense, FEMA, these types of networks they just can't go down, right? A zero downtime network is one where it's just not an option, right? A hospital group. because of regulatory reasons. You have to have redundancy. You have to have two full networks, lines going in, connecting your hospitals back to the data centers, because all the electronic records are being held elsewhere. So in financial institutions, a lot of times on these exchanges, if you start a trade and then the latency increases or you drop a connection, you're still responsible for that trade. So that's what we mean by zero downtime networks. It's just not an option for it to go down. And why do people choose cPacket when the network is mission critical and zero downtime? Because they believe in packets, they believe in the precision that we have, and they believe in performance. Those are the criteria that they're looking at for choosing their network providers and the tools that they use to analyze them, and that's what cPacket provides. So last slide, and then we'll pass it off. But you'll see this slide kind of in various versions throughout the presentation, just kind of telling you what part of the network we're working on. So this is the portfolio that we currently have. We showed you kind of the timeline, the journey of how we got from there to here. At the bottom, we've got our packet delivery and brokering and analytics. So we have both TAP-AG and full-featured packet brokers. We got the capture and storage and analytics that goes, again, from 10 gigabits per second all the way up to 100 at line rate. And again, if you want to talk about things that are going to be happening in the future or things beyond what I'm showing here, I would absolutely encourage you to ask that in our 30 minutes afterward. And on the packet delivery, we're taking that all the way up to 400 gigabits per second. Unified configuration, command and control, again, across both on-prem and virtualized, and then the work that we're doing both for AI, for network observability, and trying to discern those actionable insights from that slew of data, but also how observability is finding its way into the AI data centers that are being built at breakneck speeds.